Let's take a look at number 23, which is operations on functions. This is subtracting two rational expressions, looks like. So we got f of x is equal to 5 over x plus 3, and g of x is equal to 3 over x minus 5, and we want to subtract those. So let's take a look at adding and subtracting rational expressions. So adding, subtracting rational expressions, specifically with different denominators. Now step 1 is factor the denominators, so factor the bottom parts. Step 2, determine the LCD, least common denominator, and rewrite each fraction with that new denominator. Step 3, add or subtract the top parts and put into a single fraction. Step 4, factor the top, factor the bottom. In theory, your bottom should already be factored, because you factor your denominators in step 1. And step 5, cancel if possible. Now this problem is fairly simple, so we won't have to do like all these steps, but let's take a look at them. Okay, so we're going to have 5 over x plus 3 minus 3 over x minus 5. And step 1, factor the denominators. Well, nothing to factor here. These are simple as they get. Step 2, determine your LCD and rewrite each fraction with a new denominator. We look at each factor. Like first I'll look at the x plus 3. And we're looking for the greatest number of x plus 3's in any single denominator. There's 1 here, none here, so the greatest number of x plus 3's in any single denominator will be 1. Then we'll go to our next factor, the x minus 5. And we're looking for the greatest number of x minus 5's in any single denominator. There's none here, 1 here, so the greatest number of x minus 5's in any single denominator is 1. So that's our LCD. And that's where we're going to rewrite each fraction with. Now you have to look at what new thing's been put down below. Here we have x plus 3. That x plus 3 is still there. The new thing right next to it is the x minus 5. So we have to put an x minus 5 up on top. Basically, the rule is whatever you multiply by the bottom, you have to multiply by the top. In our second fraction, we had an x minus 5. The x minus 5 is still there. The new thing downstairs is the x plus 3. So we'll put that up on top. Well, 5 times x is 5x. 5 times negative 5 is negative 25 over our denominator. And 3 times x is 3x. 3 times 3 is 9 over our denominator. Step 3, add or subtract the top parts and put it into a single fraction. Well, remember when you got a negative out in front of a fraction, it's going to flip the sign of all the terms up on top. So when we merge these into a single fraction, we're going to have 5x minus 25 minus 3x plus, okay, I'm lying to you. Try it again. Minus 3x minus 9. Again, it changes the sign of both of those over our denominator. 5x minus 3x is 2x. No matter where you are in math, combine together like terms. Negative 25 and negative 9 gives us negative 34, I believe. Yeah. Step 4, factor the top, factor the bottom. Top I can factor 2 out. And I get this. And we can only cancel if you have two things exactly the same. When I say two things, I'm talking about factors. Like this x minus 17 and this x minus 5, they were the same. We could cancel them. The fact that only the x's are the same, we can't do anything with them. So let's see. Looks like it would be x plus 3, x minus 5, 2x minus 34, D as in David. They also put the domain on here. They set each denominator equal to 0, like that, and solve, and we get x equals negative 3 and x is equal to 5. And these are the values it cannot be because it causes 0 in our denominator. So 23D. And that checks.